This
Prashant, these are the
conference will
regular
now be
classes?
recorded.
Okay, hi everyone. Yes, Vijay, you have some question. I just started the recording.
Yeah. These are the regular sessions or what?
Yes, these are the regular sessions. Today will be day 2. We have already started with a brief introduction about the cloud computing in the
Okay.
last session, but I'm gonna start from very fresh today, from very beginning. I'm gonna start and yes, these are the regular sessions. Start from today. Yes.
Okay. Okay. Thanks.
Sure, Vijay. Okay. Okay, guys. So welcome to the first day of cloud performance engineering in DevOps. So we are done with our of the demos last week, and we're gonna start. And we have went through all the way that how we have planned to go about this. Already explained all those things in the last 2 recordings. If you are looking for the recordings, then if you do not have the agenda for all the topics and how we are going to make cover all those, please you can get in touch with Mr. Kumar. I'm gonna just last time I'm gonna just take you to this website. You can find the course detail in this link. I can forward you this link. I think most of you knows about this link, but still the benefit. Uh, and there are all the course topics that we are going to cover, and I have already stated, and you can go over the demo sessions here also. And I'm going to the first topic that we're going to take is the cloud computing, and that's what we are starting up today. I have already went over this particular link in detail over the last recording, so I'm not going to spend some more time here. Okay, I'm going to. Okay, I request everyone to be on mute. If not, I need to mute everyone. If you're not speaking, please be on mute. And if you need to speak, you can very much unmute yourself and ask. But I request everyone to be on mute. Thank you. Okay, welcome guys to the day 1 on the cloud computing. So we are starting. Guys, I request everyone to on mute. If not, I have to do it. Mute all, everyone forcibly. I don't want to do that. So please take it. Yeah. So okay. We have we just started with this topic, and we have started with the cloud computing, and this is what the data center means. When I say a data center, I want you to imagine something like this particular infrastructure, and all the servers, you can just whatever you can imagine, the limitless servers, infinite servers, a lot many virtual machines, storage services, cooling mechanism, all those infrastructure make up this one data center, and that's what we mean by data center. We'll understand why we are talking about this, but to get started with the cloud, we need to understand the definition of cloud. Most of the people are interacting with, they are confused about the cloud, this buzzword. To be just simply put, it's the same thing what is there for on-prem. It's not a big thing. It's not something which is very much unique, different setup. It's something very much similar to the on-prem environment. Like in on-prem, you own all the hardware. That's the simple part. If you are worked on the on-prem environment, so what we mean by on-prem, you are basically own the complete facility. If a guy owns the complete facility and he has purchased all the hardware, software, whatever you see here, all the machines, cooling mechanism, security, everything. If you own everything, that becomes your on-prem infrastructure. Someone else has built this data center, and if you're going to consume a few resources here, few servers, that is what the cloud means. It's just a different naming convention, but that's how it is. So in the cloud, I'm not going to purchase any of these things, the hardware, the software, the servers. I'm not going to purchase it. I'm going to rent it from someone who has already set up some these kind of data centers like AWS, or you have Amazon. That Amazon cloud service is called AWS. Microsoft, the cloud service is called Azure. Google, their cloud service is called GCP. So I'm going to rent the servers and I'm going to use this. And that's what this cloud is all about, and we will understand how can I take, so how can we make use of the servers, make sure that I can deploy my own application, the one I want to deploy in these servers. How can I deploy that? The cloud service providers, what they have done, they have enabled us with this interface. This is called an interface. Okay, I'm showing you the interface for AWS. They have enabled us with this. So what I do mostly, I log into this cloud console. I sign into this console. Okay, and I can just log into this. I sign into this, and then I get to access the servers anywhere in the world. They have, I'm going to talk about it. They have regions across the globe. Everywhere they have it. If I talk about their geographical presence, AWS geographical presence, if I just talk about that, let me just show you how much they have it, in how many regions they have, how many data centers they own. It's quite huge, and the numbers are increasing. See, they have presence in 26 launch regions as of today, and they have 84 data centers. When I say data center, they call it. They have some kind of naming conventions they follow. All the cloud service providers, they follow a naming convention. So when I say a data center in AWS term, it means availability zone, AZ. In short term, in short form, we call it AZ. So they have 84 data centers across the globe, and they have launched their AZs in 26 regions. And you can, I just showed you the regions here, the list. There is a one region in Mumbai as well. There are a lot of regions in US. In US East, they have one region. US East, they have Ohio. They have one region. US West, they have one region. In US West, Oregon, they have one more region. In Europe, they have. So their presence is global. And why global? You can ask, because they want to cater all the people across the globe. Because if, let's say, if today I have decided to build one application, let's say, for the people who belong to India. So where I should deploy? I should deploy in nearby region. So what AWS offers, they have this region in Mumbai. So if my customer base is in Mumbai, is in India, I have to select one of the regions which is near to India. So Mumbai is in India. So I'm going to provision servers, and I'm going to deploy my application in Mumbai. Same thing. If, let's say, if my customer base in Australia, so what can I do? I should prefer to deploy my application in Asia Pacific, Sydney region, because the servers are close by, so the users would get a better performance. That's the idea behind this. And there are a lot more mechanism. How can we make it better? Things like that. But just to put it simply, the closer the location, the closer your server is located, the better performance you get. The simplest formula, and that's what I'm thinking here, and that's what you should also think from a customer point of view. Right? When a customer requests something, right? I am hitting this Amazon.com, let's say this website. I am getting some web page. This web page is deployed somewhere, right? In some of the web server, in some of the compute, it's deployed. This web page is deployed. If this web page is deployed in US, so it will take some time. And if let's say I'm getting from India request, so it will take some time to get this web page, right? So that it's easy. If I have a server deployed which is near to my location, it's always a better thing, and I will get a better performance. So that's why we need servers. We need servers to deploy our application, so that I can run all those things. Whatever you see, Uber application, Swiggy application, whatever application you see. Amazon.com, Flipkart, all the websites are deployed in some server, right? And the closer the server you get, the better performance you get, right? You experience, right? And that's why what they have done, they have given this console. AWS guys have given this console that you don't need to contact me. If you need a server, go and get it. They have given a way for us to provision servers, database servers. There is a service for the database, we call it RDS for the relational database. If I need some server, database server, I can get it. If I need some servers, there is service called EC2. I can get to this EC2 service, and I can get the server of my choice, of my requirement. Get it. I can customize my server. If I need Ubuntu operating system, I can get it. If I need a Red Hat operating system, I can get it. If I need Macintosh operating system, I can get it. I can select. I have the flexibility. The user, customer, you and I have the flexibility to customize our operating system, to customize our virtual machine, right? And that's what the best thing is. We get to customize this. Just hold on, I'm getting a question here. In such a case, AWS has CDN as well as service. Yes, we know. We do have content delivery network. We call it points of presence, and that service is called CloudFront. Okay, so CloudFront is that service that is for the CDN, particularly for the, and that's what we do it. And if we are retrieving a lot of web pages, static pages from a remote location, so what do we do? So we cannot have a data center located nearby. So what we do, we configure the CloudFront distribution. That's what we do. We provision a CloudFront distribution, and then you get a better performance, right? So we do have this service. Yeah. Okay. So coming to the global presence, so we have AWS has given us this particular console, this on-demand, to get the on-demand self-service done. So you don't need to contact AWS, as I was speaking. So AWS has given you this particular UI so that you get to have the server of your own requirement, of your own, whatever you need. If you need tomorrow, if you need a database, you can get it. Database server, you can get it. So everything is there, and they have automated this for everyone, and that's what you get it. You get RDS, you can select RDS. If you need a SQL database, you get all the options in RDS. RDS stands for relational database. If you need a NoSQL database, you can get it NoSQL database as well, like DynamoDB. You can make use of that. You have a lot of options in RDS. If you select this RDS, so you have options like you can get MySQL database, Oracle database. You can get MariaDB database. You get a lot of options. A lot of options you get it in RDS as well. So we have got Microsoft SQL Server, PostgreSQL, MariaDB. You get to see a lot of options here. Right. Okay. So coming back to our original discussion, the way we were. So that's what this cloud service provides. So they gave you the infrastructure. They invest a lot in setting up these data centers. So you and I, the customers, can provision these servers and can do our work. And what we need to do, we need to pay some charges. We need to pay something, some amount for the server that we use, for the compute time that we use. That's what this cloud is all about. And as we have discussed, right, in on-prem, what you have, you get to access all these components, the data centers, the networking, the storage, the servers. You have to purchase everything, right? You need to set up the data centers. You need to have the networking in place. You need to make sure that internet is always available. you have proper backup, and they have to maintain everything, and you as a user get to own everything, purchase everything. But in the cloud, I'm not going to invest all these things. So what I can do, I can get it simply by paying some rent, because I'm just going to rent the servers. If I need the servers, I'm going to approach AWS, and what they have done, they have given you this console. I can go to EC2 instance, I can provision some servers, I can deploy my application, make it functional, and I can just pay for what I use. Pay as you go. That's what this cloud means. Pay as you go. So you will be only paying for the compute time that you use, for the duration that you use. You're not going to pay anything more, because and you don't have to purchase this service, right? You can just take it for rent, and you can just make use of. So that's what these things, the cloud is all about. So are we good with the cloud definition part? I just want to stop for a moment here. I want to understand. What do we mean by cloud here? Is there any confusion here? I'm going to talk in detail, but I just want to understand the definition part here. Are we all good? Yes, no? You can just put in the chat window if you have,
Yes,
if you're following, we'll discuss things. Yeah? Okay, Pradeep is saying yes, he has understood all the things. How about others? Any confusion? Is there anyone who has joined today for the first time? Or if for everyone, it is the second session? Okay, Abhishek says yes, he has understood things. How about others? Please be responsive so that I get a better feel of the session and about the everyone. Okay. Okay, so moving ahead on this. Okay, I see a lot of you. Yeah, thank you, Sai. Thank you, Himadri. Thank you. Okay. So why do we need cloud? So what have you thought? Like, if you just till the time we have discussed why we need cloud for the cost reduction. The first point is this: I don't have enough capital to set up my data center. Setting up data center is a very costly thing, right? It's a very costly thing. Not everyone can do that. So why would I need to use cloud? Because it will help me to reduce the cost. The first important thing, the scalability. It is because if I need to scale, let's say in future, today I'm using 2 servers, let's say, and tomorrow I need to use 4 servers. So I don't need to purchase things. I can easily scale my servers. I can simply just one option. Like instead of 2 servers, I need 4 servers, and you will get it. Not a big thing here. You can easily scale your application, and you can get whatever you need. If you need more hardware, more resources, you can get it. You just need to pay for that, right? Disaster recovery. A lot of companies, those who have on-prem infrastructure as well, what they do, they use cloud as disaster recovery. They store all their data in the cloud, so that if they lose by some region, earthquake, natural disaster, whatever their on-prem infrastructure they have, they may lose it. So just as a backup, what they do, they use cloud as a disaster recovery as well. Data security. Cloud is secure, and we will understand more about its security when we talk about a lot of security services that we have in cloud. So obviously, cloud is secure. That's why people are preaching cloud. We get a lot of control over your services as well. And mobility. Today, if you need one server in one AZ today, tomorrow you want to change that, you can package everything, and you can deploy in some other server as well. You get a better mobility as well, right? And automatic software updates. You don't need to worry about the software updates. It will be done automatically from the cloud provider. You don't need to worry. So coming to the definition part, this is the simplest definition I could arrive to. So what is cloud computing? So cloud computing is a term used to describe the use of hardware and software delivered via network. That's what it is. The use of hardware and software. Can you appreciate this part, right? See, everything is there for you to use. Everything is there for you to use. You can make use of all the hardware and software in the world through the internet. What you need to have, You just need to have internet connectivity. Everything can be achieved remotely. If you want to deploy an application in US, you don't need to be present in US. There is already a data center set up in US, in Ohio, in North Virginia, in North California, in Oregon, already data set up. And what these cloud service provide, they provide you a mechanism, an interface. This is the management console. They provide you this management console, and you can very much just change the region from your Mumbai to North California, and you can very much create a server there, deploy your own application, do a load balancing setup. You can have multiple auto scaling configured, and you are up and running. Your business is up and running. So that's what is all about. The cloud computing definition is a term used to describe the use of hardware and software delivered over via network. Cloud computing is computing based on the internet. That's what it is. Very to be put simply. And the characteristics, what all are the characteristics? On-demand self-service, right? Whenever I need, I will get the service. And it's a self-service. I don't need to ask someone else to do it. I don't need to engage AWS people. Okay, no, it's your cloud service provider. You know the application better. No, they have given you this console, and that's what you're gonna learn in cloud: how to make use of this console, how to create servers, how to work around all that you have, what all services you have in security. When they launched AWS, they with three services. EC2, S3. S3 is a storage service. Uh, just to impress you, all your Netflix content that you see, all the Netflix or Amazon Prime videos content you see, is stored in S3. S3 is a simple storage service. No one has able to exhaust the storage that S3 provides. It is having such a storage thing. S3 is what it was one of the first services which was launched along with EC2 and SQS. SQS is a simple queue service. You need that for the queuing mechanism. You don't want your request lost, so that's why you need SQS. So EC2, S3, SQS, these three services were launched when AWS was launched back in 2008. And we will understand about all the services that they have to offer. Most of the services that we need here. They have services like Cognito, guard duty. They have for the security, for the threat detection. They have a lot more services in security. We'll go about that slowly as and when we'll be going over the sessions. So on-demand self-service, broad network access, huge network access, rapid elasticity. I can get the servers when I need it, how much ever I need it. There is no such limitation that I can only get so much. Everything would be measured. Whatever you use, if you're using one, so that's what they have, this billing mechanism as well. One dedicated service is for the billing. Whatever you use will be captured here. And you can see where you have spent. You get monthly bills. They will give a proper billing. I cannot see it right now because I have logged in as one of the users here. But if I log in as a root user, I'm going to tell you how to log in as a root user. Everyone will have this account created. I will guide you how to get this done. And for everything you will get it. So let me log in as a root user. Okay. I'm going to sign out from here. And the first thing, I'm going to show you how the billing looks. So everything would be a measured service. Okay. Everything would be, let me just using this root user. Let me just capture this. Just hold on. I'm just taking the email address. Okay. Just 1 second. I need to provide this is a common thing that he would ask to do that. M7. Okay. I hope I have typed it correctly. Yeah, that's fine. and it will be followed by MFA. I have also enabled an MFA, multi-factor authentication. I will also tell you how to get this done, multi-factor authentication. Let me just, I'm capturing one token, it is coming to my mobile. I'm picking my mobile and to get this. Okay. So now I have logged in as a root user. So root is a very secure user. Now if I go to this billing service which I was showing you, I will get the bills. Whatever I get it, I'm using this particular AWS account from a quite long time, and you would see a lot of bills. I know how to make sure that efficiently use the resource, so I don't get billed a lot because I know how to make sure that you don't get enough bills. So I will just guide you on that as well, how to make sure you don't get bills, and how can you save on this. I'll let you also create some alerts here. So if you are getting billed, you will be notified as well. I will guide you on this. Okay. So I'm just telling it's a measured service. Everything would be measured service. And resource pooling. Yes. You can have as many resources as you want whenever you need it. So, and a very important term is virtualization. I have given here cloud is equal to virtualization and automation. When I say virtualization, what I mean, okay, I just want to understand from you guys. You guys are working in on-prem for such a long time. When I say virtualization, what do you mean? Anyone can speak here. What is virtualization? What is the main goal of virtualization? Anyone? I have already explained that in the first session. If someone had attended that workshop or in the first session, I have already explained that.
Efficient use of hardware resources.
Perfect, Mohammed. Yes, efficient utilization of resources. That's what virtualization is all about. And what cloud service provider has done, they have bigger servers, right? They had bigger servers. And what they do, they have installed a virtualization software on top of that. And by using that, what you do, you can create VMs of your own requirement, of your own compute size. You can very much use that. You can configure it. So that's what the virtualization is all about. And everything is automated, right? You can see everything is self-service. Everything is automated, right? That's why I have just given this stressed on this. Cloud is equal to virtualization. If you want to experience the level of automation they have, you just need to look into the cloud console, management console. What level of automation they have done it. The servers are somewhere else, remotely located from us, right? And they have given you this console, and you can the server of your own choice, of your own requirement, of your own need. You can install whatever the application you need. You can configure all the security services that it needs to have. Everything through a remote connection. It is automation. Everything is getting automated. They are doing automation like no one. All the cloud service providers, the major cloud service providers out there, it's all about automation. Right? It's all about automation. So virtualization and automation are two important terms which are connected to the cloud. And I want you to acknowledge that and appreciate this. So the cloud is using virtualization and automation to provide users with self-service computing products that provide infinite scale at low cost. This is why cloud is in demand. Everyone wants to learn cloud, and it's just picking up, right? And you can just understand from this that when AWS was launched in 2008, they were trying to build some kind of compute and infrastructure for their own website, Amazon.com, but they end up deciding that they can leverage this to everyone, and that's when they decided to launch this AWS, and they launched with just 3 services, mind it, EC2, S3, and SQS. These 3 services they came up with. Today they have more than 200 plus services. Based on the requirement, the AWS is the most customer-centric cloud service provider. They have a lot of automation in machine learning, Internet of Things, in game development, whatever you just name it. If a customer needs it, they get one service, they automate stuff around it, and they make sure that the customer, they are solving a customer problem in general, in generic problem, so that it is applicable to everyone. Database. Earlier, if I need to use a database, what you are doing? Let's say in on-prem, what you do? You get a server, and then you install database, any database, Oracle database or Microsoft SQL, any database you install, or MySQL, you install it manually. But what they have done, they have automated the installation process also. It's all about button clicks, it's all about button clicks. If I let's say today I decide that I need a relational database, let's say Oracle database or MySQL database, let's say MySQL database. Today I decide MySQL. I don't need to know installation process. Installation is not at all a problem now. And if you're learning how to install it, it's a waste. Why it's a waste? Because they have automated this. If I go and click on this create database, I just go and select MySQL, and I just select few options, and I just click on create it. I'm giving you here a create database. Okay, I get to select MySQL. Let's say today I decide I need to have a MySQL server with me. I need to use that. I can use any version what they have it. I just need to decide on the version. Let's say I just use latest version 8.0.27. Let's say this latest version I'm interested in. I select that, and I just give multiple options. So if this particular MySQL is for the production environment, dev tier. Let's say for production, I just decide that, or let's say for development activity, testing activity, I just decide that. Okay, so name would be this. They're giving you that the admin name would be this. You want to set the admin password, I can set this up. I can set the password also here. I can select the server size where I want to deploy my database. I can select on it. I need a 16 vCPU, 64 GB, or 8 vCPU, 32 GB RAM. I can select. I can have a server of my own choice. I can make sure I can allocate the data, how much space I want in my. Let's say I need 512 GB. Let's say I just decided on that. I can go till maximum 65 TB. Okay, so don't worry. I'm not having less to choose here. I can go to 65 TB. Automatic storage, so auto scaling. If I will adjust this much of space, if I check this box, automatically it will be auto scale. I will never run out of space. Everything is automated. After doing all these things, I can deploy in multi-AZ deployment. Just for the high availability sake, I can select that I want to deploy this particular database in multi-AZ. I have given all those things, right? I have given the security credentials, the security part, who all can access it, public access. Do I need to provide public access or no? For database, we never do that. It needs to be very secure. I can select BPC. They will end of it. They will give you this cost per month. It will be charged so much. And the moment I click on create database, your database would be ready in 10 minutes. They have taken all the details from you. And if I just click on create database, they would run a lot of shell script. All the database installation process would be run. And in just 10 minutes, you will get database. The installation is not a problem now. They have automated it. That's why I'm telling you, stressing this point. If you want to look at the automation, the level of automation, look for the cloud service providers, what have done it. And not just this. Tomorrow I decide I don't need MySQL. Tomorrow I need, let's say, Oracle database or Microsoft SQL Server. My requirement changed. I need a NoSQL database. You have all the options in the world. Go and get it. Just delete the MySQL database and just create something else. They have all the options. Because you're not purchasing anything, they would charge. As I told you, right? They have given you this upfront cost that if you want to use this database for this long, and if you want to run in this particular server compute size, if you need auto scaling in place, backup in place, you will need to pay so much. That's a very less amount. And like if you talk about the setting up the data center and purchasing everything, right? So that's what they have done it. They have automated this. That's why I'm stressing this. Cloud is all about virtualization and automation, and that's what all it is. And I was explaining, they launched it with 3 services. To today, they have more than 200 plus services. 200 plus. For robotics, they have it. Tomorrow, something else come up, some new technology comes up. They will automate it. Today, I'm telling you, they will automate things. It's not going to go away anytime because and today we are using this in the console. Tomorrow, they would give you in mobile. Who knows? Today I have to open a laptop to get things, get provision servers. Tomorrow they would simply do in mobile. And in mobile, only through mobile, you can build your own application. They can do it. The automation is at its peak. Uh, when I look at the cloud service provider and what they are doing, right? So what is the advantage? Trade between capital expense, operational expenses. You pay on demand. You don't own any hardware, right? So what it has done, it has reduced total cost of ownership and operational expenses. Benefit from massive economies of scale. You can get it any server, right? And are reduced as AWS is more efficient with large scale. Stop guessing capacity. You can just or the enable auto scaling. Let's say if you are on a server and say you are running your application with 2 servers, any configuration, let's say 4GB CPU and 16GB RAM, let's say, just keep it simple that way. You are running your application workload with 2 servers, and let's say most of the time you're expected to have 100 users accessing your application, let's say in one point of time. And let's say between 10 to 12 or 10 to 2, 10 a.m. to 2 p.m. for the 4 hours, you may expect a higher load in peak business hours. Let's say that you may get 300 user load workload. 300 users can also log into your application and they can access it. If you were working on-prem, you have to make sure you have to set up your production environment in such a way consistently for maximum of 300 users. Whether five users are accessing or 50 or 100. Even for 1 hour, if 300 users are accessing your application, you know that in one point of time, the user load can go up to 300 users. In on-prem, you don't have any other option. You have to pre-configure your infrastructure for 300 user load all the time, but not in cloud. Only for the peak hours, you can schedule that you need more servers. You need 6 servers, not just 2. And for the rest of the time, you can manage your workload with 2 servers. What you're doing, you are saving on the cost. Flexibility, right? I hope you understood the last point which I mentioned, everyone. Can I get a quick acknowledgement if everyone understood the last point, right? About the flexibility, or about the auto scaling, what cloud provides. If you have any questions, please let me know. I can repeat that. Increase speed and agility, right? Stop spending money running and maintaining data centers. Someone else do it for you, right? AWS, big players are doing it. You are just going to leverage few servers and going to pay them. That's all. It just takes go global in minutes. Yeah, everything is automated. Everything is automated within few hours. You can build your infrastructure, your app server, your web server, your database server. You can load all the workload and you can go up and running. Problems solved by the cloud. What all problem cloud solves for you? Flexibility. Right? Change resource types whenever needed. Today, you were using 4GB CPU, 16GB RAM. Tomorrow, you think that's not enough. I need more. Because you have not purchased it. You can ask AWS, boss, you please take it. I don't want this server. You give me 8GB, 32GB RAM. I need that. They would say, fine, thank you so much. No problem at all. they would take back 4 vCPU, 16 GB RAM, and they would deploy your application in 8 vCPU, 32 GB RAM without any hassle. Because someone else would be needing that 4 vCPU and 16 GB RAM, which you do not need right now. So you can change the resource type whenever you need. Cost effectiveness, pay as you go. You will only pay for what you use. If you are using more additional compute instances, compute servers only for 2 hours, you're gonna pay only for the 2 hours. Additional pay only for the 2 hours. For the rest of the time, if you use less servers, you're gonna pay less. Pay as you go. That's what their principle is. Scalability, accommodate larger loads by making hardware stronger for adding additional nodes. That's what we talk about auto scaling. There is a feature called auto scaling. If I talk about the EC2, the one I was showing you some time back, if I go on the EC2 service, there is a section called load balancing and auto scaling. You just need to configure it. Okay, load balancing and auto scaling are very important for the performance point of view. You need to configure this load balancer, which is going to load balance the traffic across all your servers, and auto scaling. If you need more servers, on what criteria automatically the additional servers would be provisioned. So you need to configure these things. Once you set this up, it will be taken care of. If the more users are accessing your application, you need more hardware, it will be automatically scaled. If you need less servers, it will be automatically scaled down, and you'll be paying less. It's all about knowing how to configure auto scaling group and load balancing. That's what we're going to discuss, and I'm going to show you how do you create load balancing, what all different algorithms you have, round robin, you have least outstanding requests, on what criteria the request would get load balanced across all the servers, how wide, what type of different options you have auto scaling. Can I schedule only for the Wednesday? If you have a business which experience only on Wednesdays you have higher load. So what you can do, you can only auto scale only for Wednesday. Whenever Wednesday comes, you will get more service provision automatically once you set that up. That's called scheduled auto scaling principle. That's what we'll discuss about these things here. High availability and fault tolerance. Yes, they make sure that it is highly available. That's what the main intention is. You always want your application to be highly available. You don't want your application to go down. Right? You will understand ways. How can we make sure that my application is highly available? Agility, rapid development, test and launch software applications. These are all the benefits of the problems solved by the cloud. Right? We leverage cloud in 3 ways. Okay. Are we doing good till this point of time? Can I get a quick check? Yes, no. Are we doing good here? Do we have any questions?
Yes, sir.
Okay, perfect. Sounds good. Okay, yeah. See, so there are 3 ways you can use cloud. Okay, so you can use cloud that you have understood. You have understood the problem it solves, and what advantages you get in the cloud or on-prem. That's fine. But what are different ways? These are called service models. You can use cloud as an infrastructure as a service, platform as a service, or software service. Can anyone tell me what is software service? Can anyone tell me one example of software service? I just want to understand if anyone understands this.
Gmail is the one.
Right. So basically, you don't get to control over the hardware. That's what, if you ask me, that's what I will define. In the software as a service, I don't get the control. The customer, I mean the customers. Customers do not get the control over the hardware. The hardware is being managed, being run by the cloud service provider. AWS, or let's say, as you given this example of Gmail. So Google maintains the hardware in their data center. They have a lot of servers, many things are configured, right? Many things. And what they provide, once a user types in gmail.com, it it looks like this. You log into your application, right? That's what it gives, right? So software as a service. All the things that you see here, not just that, right? Not just that. Let me just do this. Not just that. All the service that you see here, Google search, Maps, YouTube, whatever you see here, all the examples of software service. Do you maintain a hardware on this? Do you own any hardware? Do you know where it is? You just go on YouTube and play a lot of good stuff, and you have so many things hosted. Do you think how much it takes to store so many videos? What mechanism they have in place so that they're efficient on the storage side? They do a lot of compression. They have so many things. They have all the database, all the hardware set up, and you don't get to see the hardware which supports this application. This application is deployed in such a huge list of hardware and software. I can just imagine so many people uses it and no one gets a bad performance. How they're managing it? Google run most of its work in Kubernetes. We'll talk about that, Kubernetes. But just understand the scale it offers and how much data, how much hardware it needs to run, support that much of user load. So all these are example of software as a service where you don't get to know, where you're least bothered about the hardware. You are just only for the application, software as a service, looking only for the software. Right? These are the examples of software as a service. Can anyone tell me any example of platform as a service? Anyone here? I have. If you have attended a few of my sessions, I have already told you multiple times. I just want you to think and be interactive so that you can understand things better. Tell me any example of platform as a service. What is platform as a service? Okay, no problem. See, in the platform as a service, the user to write the code. Platform as a service. They want platform as a service. They want some platform. And as a user, I'm only interested. I'm only my focus write the code. That's what the platform as a service means. If I have the control over the code that I'm writing, and I'm least bothered. If I'm writing a Java code, I'm least bothered what Java version is installed, what type of runtime is installed, which hardware runs this Java runtime. If I'm writing a Python code, I'm executing Python code, I'm least bothered about Python runtime, how it is executing my code, how it is making sure it is running perfectly fine. I'm least bothered about those things. The user is only focused on writing the code. That's what the platform as a service. Removes the need for your organization to manage the underlying infrastructure. Focus on the deployment and management of your application. That's what you focus on. Only on your application. You only focus on application. You can leverage, you can reach out to AWS and you can ask them that I want to only focus on my application. I want to deploy it. I want to run. I want to write the code, deploy it. Please provide me all the infrastructure requirement. In the software service, they are writing the code, right? They have written the YouTube code, Gmail code, Google Map code. They are doing it. But in the platform as service, they are going to give you the platform, but you cannot control that platform. They're giving you the platform for you to consume and write your code and deploy your code. Your online editor, whatever you have it, right? On all the online editor, any Java, Python, whatever code editor, like anything, you write, right? You execute whatever any application you have. So many applications you have. What you do, you just focus on running the code. That's what you do, right? If it is code sandbox or whatever, you are only focused on writing the code. Start coding for free. You are only focused on this runtime environment. Only focus is only on your code. You are least bothered where this C++ installed, which region, which database, which operating system, how it is installed, who has installed, your list border. Those are the examples of platform as a service. They have given you this platform to write your own code and execute it. I can very much execute my code, and I can download this code and I can deploy it. So things like that, right? So platform as a service. I'm going to talk about these things in detail about the control that you have. Let me go to the next slide and you will understand things better. In the software as a service, user do not get the control over anything here. I consume as a customer, I just consume the software, Gmail, YouTube, Google Slides, Workbook, Worksheet, whatever I just showed you, Google Map. I don't get the control over any of these things. Do you have the control over the application? Can you bring the YouTube down? Can you do that as a customer? No, I cannot do that. Because you don't have the control. All these things, data centers, network, storage servers, operating system, database, application, all these things are maintained by the cloud service provider. They can do it. Google, yeah, the engineer who is looking into that, they can do it because they have the server control. In the platform service, you don't get the control over these things. You only get the control of the application. That's what you get the control over. The customer gets the control over the application it runs. And all these things, they ask cloud service provider, please provide me all these things. I will pay you. Customer, that's what the customer pays cloud service provider. AWS, GCP is not here to do charity work. They are here to do business. Right? They want to earn, and they are giving the service for that. So they are going to give you all these things. And as a customer, you're going to focus only on the code part, your own application code running deployment, and they will be charging for this thing. The third service model called infrastructure as a service. It is having a much more control over other service model. The users get to control over the operating system. When you provision your EC2 instance, right, you get the control over your operating system. What operating system you want to select? I can select macOS. I can select Red Hat. I can select Ubuntu. I can select Red Hat, Ubuntu, SUSE Linux, Windows. I get to decide on my operating system. I get to decide on my database, which database I need. I get to store my data, and I need to provide security for those things. If you want the control over these things, you go for infrastructure as a service. That's what you go for. Most of the companies that we work on, they use cloud service provider as infrastructure as a service. They want to control over these things. They don't want to set up the data center. It's a very costly affair. They don't want to set up the networking. That's their thing. They don't want to purchase all the hardware. They don't want to do virtualization. That's their thing. After this, the customer get to control over these things, and the cloud service provider manages all these things, all these components. Those are called infrastructure as a service. And when you own everything and manage everything, that's on-prem. That's on-premise. You have to purchase everything. You have purchased and you own everything, every bit of it. You're maintaining, purchasing everything. It's you who have done it. So that's on-prem, traditional IT environment, infrastructure. That's how it is. Right? So that there are three service models that we have. Any questions on this?
Roshan, can you please give an example of a PaaS system, platform as a service?
Okay, see, within AWS itself, you have a service called Beanstalk. Okay, Beanstalk.
Apart from AWS, okay. Like in real time?
As I gave you right, the online editors where you get to write your code and package your code, deploy your code. You can run your code. When you run this code and execute this code, you are least bothered about everything else, right? You're least bothered about the security, database, operating system, you are least bothered about these things. You are just focusing on the application you are running on or you're developing, right? So that's one of the examples, online editors, code editors that you get to see. Or in the Beanstalk, within AWS, they have Beanstalk. What they will do, they will ask you what platform you want to run your application. I can give you. Do you want to upload your code? Yes, I want to upload my code. Once I upload this code, this code, they would deploy this code. So as a user, I'm least bothered about the platform. I'm just asking for the platform. I need to use a Python platform. They would give it. What I'm doing, I'm just uploading my code, and I'm deploying my code and getting my application up and running. Right. Those are examples of that. So, right. Any questions on this, guys?
Yes. Is it okay? You can get us the PPT.
You will get it. You will get it once you enroll. You will get it. Yeah. You will have all the PPT access. So once you enroll to my course, you get to not just see it. You get to own the PPT for the lifetime. You'll get lifetime access. As I showed you, I maintain these kind of folder structure, shared drive. So this is for the last batch, and I have given access to everyone who have enrolled for the last batch here. All the people, those who have enrolled, they get to have this PPT access lifetime. Anyway, you will have the recording, right, shared with you. So yeah. Any more questions? We are done. It's about time. We're gonna continue our discussion. If you ask for examples, so Beanstalk, Heroku, Google App Engine, GCP, those are all the examples of platform as service. So there are a lot more services. Yeah. All the online editors, as I mentioned, you're right. So all the examples of platform as service. I'm going to talk about a lot of detail for this things. Okay. Are we good, guys? It's about time, and if there are no more questions, we can stop the recording and can tomorrow, yeah, same time. All good?
Yes.
Yes, sir.
Will you be organizing on Saturday?
No Saturday, only on weekdays.
Oh, Mondays to Fridays. Okay.
That's right. Any question? Any more question?
Roshan, can you share these docs and PPTs?
Yes, you'll be. I'll be sharing that, Vijay. Yeah, I'll be sharing that.
Okay.
Just wait for a couple of more days, and we'll be sharing that.
Okay.
Yeah. Okay, guys. Thank you very much for your time. We'll connect tomorrow. Thank you.
Okay.
Thank you.